Hey everyone, in this video I am going to explain to you how to find the domain and range of a composite function. Let me quickly write the question first of all. So the question is that if we have a function f of x that equals x plus 4 and another function g of x that equals x squared plus 2, then we need to find the domain and range of the composite function f of g of x. So now in order to do that, first of all, we will need to put the value of the function that is inside the parenthesis in this composite function, which is g of x. And we know that the value of g of x equals x squared plus 2. So we will put that here. So then we will get it equal to f of x squared plus 2. Now after this step, you can see that for f, the required input is x squared plus 2. So we will go back to the original function f of x, and here in place of x, we are going to put x squared plus 2 everywhere. So here it will become f of x squared plus 2 equals, here in place of this x also we will put x squared plus 2. And then outside the parenthesis we have 4. So we will have f of x squared plus 2 equals x squared plus 2 plus 4, which I am writing here. So then we will get f of g of x equals x squared plus 6. So this is the required function, and for this function we need to find the domain and range. Now I have explained to you how to find the domain and range of any function in very much detail in one of my previous videos. I am putting the link in the I button, so you can watch that video if you need to be more clear on this topic. So we have found that what our composite function is equal to. I'm just going to write it down here again. So f of g of x equals x squared plus 6. Now here we need to find the domain and range of this function. Now to give you a quick reminder, domain means a set of all the input values that the function can take. And here you can see that the input is x. So we have to find out what are all the values that x can take. Now if you see here carefully, x can be any number. You can put anything in place of x. You can put 1, 2, 3. You can put -1, -2, -3. You can even put x to be any decimal number like 10.5 or fractional number like 1/2, anything. So that means the domain of this function is going to be the set of all the real numbers. Now we have to find the range of this function. So to do that, let us assume some random values of x and see what output are we getting. So let's say that we can take x to be 1. In that case, x squared plus 6 will be 1 squared plus 6. We can take x to be 3. In that case, x squared plus 6 will be 3 squared plus 6. That is equal to 9 plus 6, that is 15. I can take it to be even 2.5. In that case, 2.5 squared plus 6 will be equal to 6.25 plus 6, that is 12.25. I can even take x to be 0. In that case, x squared plus 6 will be 0 squared plus 6, that is equal to 6. For a negative number, let's say -5. X squared plus 6 will be -5 squared plus 6, that is equal to 31. You can take as many values as you want to take for x, and where x is any real number. Now what I'm observing here is that x squared plus 6 is always coming out to be positive. Now the question is, why is that happening? Can't it be a negative number? Now, I think you should have the answer to this question. Try to figure it out yourself. Can x squared plus 6 ever be a negative number? Because the examples that I have tried just now are all giving me positive answers. So I would like you to try with 5 or 6 more input values for x And then you will observe no matter what you are doing, you are never getting a negative value for x squared plus 6. Now the reason behind that is quite simple. Here the function is x squared plus 6 and x squared can never be negative. You can try this out, right? You take the square of any negative number or any positive number, it's always going to be positive. Like if I take the square of 5, that's 25. The square of negative 5, that's also 25. So this is always going to be positive, or it can also be 0. When it's going to be 0, when your x is 0, then x squared is 0. That means this x squared is always going to be greater than or equal to 0. And then you're adding 6 to it. So of course you will always get a positive answer. So here we are clear that the possible output values, or basically the range, can never be negative for this function. So here we are clear that the range is going to be greater than or equal to 0 for sure. But now my next question is that what is the smallest output that this function can have? And the answer I have already given to you in the examples that I have given you to find the value of x squared plus 6. So try to figure out. Again, I will repeat my question. What is the smallest output that this function can have? Now, the answer to this question is 6. Because you can see here the smallest value of x squared is going to be when x is 0. Because in that case, x squared will be 0. And corresponding to it, your output is going to be 6. And after that, you can try putting any other value of x. Your answer is always going to be greater than 6. That means here the smallest output that you are having is 6. And after that, your answer can be any number greater than 6. That means the range of this composite function f of g of x, I'm going to write it down here because there's less space. So the range of this composite function f of g of x is greater than or equal to 6. 6 is the smallest value that it can take because x squared's smallest value is 0. So this is the range of this function. That's all for this question. I hope you were able to understand this. If there are any questions, please let me know in the comment box.